Alright guys, welcome to this page of the notes, and really all I'm doing here on this page is I just go through with you again the reason why I have to set the denominator equal to 0. I mentioned right here, just as with fractions, a rational expression is undefined if the denominator is equal to 0. So to figure out those restricted values, we take our denominator, which was an x squared minus 1, right? We set it equal to 0 and solve. I get x equals 1 and x equals minus 1. I then restrict by a domain by eliminating those values, meaning you can pick any value of x you want to. Whatever floats your boat, you just can't pick positive 1 or negative 1 because that'll give you division by 0. Let's really kind of drive this point home by doing another example problem. So here's what I've got for you. What I want you to do is we're going to simplify the expression. So here's my expression, polynomial on the top, polynomial in the denominator. We're going to have to use our factoring methods to take care of this. But then I ask you, under what conditions is the expression undefined? You're going to have to restrict the domain. Let me know what values of x, give me division by 0, and then eliminate those values of x. Here we go, let's just jump right into this. In the numerator, 5x times the quantity x squared plus 4x plus 3. You should hopefully immediately recognize x squared plus 4x plus 3 as a quadratic expression. It is quadratic because the x is squared. So that takes me back to chapter 4. I got a number of factoring methods, but right away I recognize it's a trinomial. It's a 3-term polynomial. It's quadratic because the x is squared. And I know that it's going to be factoring a general trinomial because this 3 is not a perfect square. So it's not a perfect square trinomial, it's going to be just a general trinomial. What that means is, if I'm lucky, it'll just factor into two binomials. So let's review how this works. First, I need two things that multiply together to give me an x squared. Well, that's the easy bit, x and x. If I multiply x times x, that gets me an x squared. The slightly trickier bit is I now need two numbers, here and here. These two numbers must multiply to give me a positive 3, and these two numbers have to sum or add together to get me a 4. Well, actually, that's not that tricky. A plus 3 and a plus 1 is going to do it. 3 times 1 is 3. 3 plus 1 is 4, and so I've factored that general trinomial. What about the bottom? Well, we take a look at the bottom, and it's already it's not finished, but I do have two factors in the bottom. Now, the x minus 6, there's nothing I can do to that, right? X and a negative 6, there's no GCF that I can pull out. They're not perfect squares, right? X minus 6 is just a factor I can't do anything with, so we leave it the way it is. But then I take a look at the next one, x squared minus 9, and again, hopefully, if you're familiar with factoring, if you're not, go back to chapter 4, section 3. We talked about a method known as difference of squares, right? You should really kind of jump out at you. X squared is a perfect square. 9 is a perfect square, and they're being subtracted. X squared minus 9. That means it's a difference of perfect squares. Well, if you go back and review how difference of squares works, you'll know that it just simply factors into two binomials where it'll be x, and then one has to be plus, the other one has to be minus, and it's whatever perfect the square root of 9 is, which in this case is 3. So it'll be x, x, there it is, plus 3, and x minus 3. Again, if you were to FOIL these together, right, FOIL it out, you get right back to x squared minus 9. Difference of squares is going to show up over and over and over in this chapter. Really, really like difference of squares a lot. So you're going to see it plenty. Anyway, I have now factored the numerator and the denominator. Now I look for those GCFs, and I can clearly see I have an x plus 3 in the top, x plus 3 in the bottom. Again, those are going to drop out, and I'm left with 5x times x plus 1 all over x minus 6 times x minus 3. Now what I need to do is I need to find my restrictions. What is x not allowed to be? Well, again, in order to do that, you just take your denominator, set it equal to 0. X minus 6 times x minus 3 is equal to 0. It's already factored. That is a product, x minus 6 times x minus 3. So the 0 product property allows me to split them up. X minus 6 is equal to 0. X minus 3 is equal to 0. Solve each of them for x. And what I find is that my restricted values are 6 and 3, meaning x cannot be a positive 6 or a positive 3. If you let x be 6, positive 6 or positive 3, you're going to wind up with a 0 in the denominator, which is undefined. It's not allowed. So my final answer is 5x times x plus 1 all over x minus 6 and x minus 3, where x cannot be a 3 or a 6. And again, the reason for that is if x were 3, right, I could plug a 3 in here, no problem. But if I plug a 3 in here, 3 minus 3 is 0. 0 times anything is 0. I wind up with a 0 in the denominator, and that's not okay. Same thing with 6. I could plug 6's in the top all day long. But if I plug a 6 in here, 6 minus 6 is 0. 0 times anything is 0. I wind up with a 0 in the denominator, and that's not okay. So this is simply telling you, pick any x you want to. Pick anything at all. You just can't pick 3 or 6. We've restricted the domain. These are the values of x that are not allowed. Head on over to the next page of notes. I have way more of these for you to practice. Really more now just to get practice with factoring. So head on over to the next page of the notes. I'll meet you guys there.